everyone, and welcome to today's SQL Office Hours session. Today, we're going to start with a scenario that some of you developing web applications of any type might have encountered at some point. Let's say you've got a form for entering data, and you might want to have it work in two modes. One for creating new entries, so new data you're going to insert to the database, or for updating existing entries. So we've got two modes that we could use this form in, and you can use the same form for both of them. The interesting question here is, what do you do when the user hits save? How do you process the data that they have sent to you? Essentially, we need to decide, are we going to do an insert if it's new information, or are we going to do an update if it's existing information? And there are various ways we could approach this. One method is you could try and do the insert first, and then say, assuming you've got appropriate primary and or unique constraints on the table, of course, assuming you've got the appropriate constraints on the table, if those values already exist in the table, catch the dupe val on index exception, and then try and do the update. So this kind of works, again, assuming you've got those constraints there. I hope you all do, but it's always worth remembering we don't always have the best data models to work with, so they might not be, or they might be temporarily disabled for some reason or another. So we need to have those constraints. But this kind of uses exception handling as a way for kind of process flow control, which is generally considered to be not the best idea, okay? So this way works. We can do try the insert, and if that doesn't work, do the update. The alternative, or one alternative, is to do the opposite. We can try and do the update first and say, if it changed nothing, then assume that that is an insert. So we've got all our values, try and update an existing row. If we couldn't find an existing row, assume it must be an insert. And we can do that using the SQL sent row count attribute that tells you how many rows were affected by the last operation. Now this sounds good, but there is a potential problem here, right? If you're doing things properly in web development, you need to do lost update detection. So if two people are using the application at the same time, make sure they don't overwrite each other's changes. For example, let's say you and I, we both read the same customer's data at exactly the same, bring up the same customer record at the same time. I make some changes to it, save them. You make some different changes to it, save them to the database. You have now overwritten my changes. We should have some check in the update to make sure that when you save, I haven't saved in between those events. So it could be the reason we update no rows is not because it doesn't exist, it's because we've correctly handled lost update detection. So this approach, again, it can work, but might not, particularly in multi-user environments. So we've got our various ways of approaching this, and both of them kind of have their flaws. They're not exactly pretty, either of them. And then there's the kind of performance aspect of this to think about as well. You probably want to do whichever you think is the most likely operation first. So if generally people will be using this form to enter new information, we want to try the insert first. If not, if generally people are using it to update existing information, you want to try the update first. The problem is that's generally kind of unknowable, right? It's hard to know that information in advance. And even if you do know it now, it's likely to change over time. Let's say you're deploying a new application, new tables, it's likely most things will be an insert, but over time, as the data volume grows, it might switch and things become an update over time. So there's lots of kind of things to think about, potential pitfalls with these various methods. Fortunately, there is a nice, simple way out of this mess and dilemma that we can use, and that is the merge statement. So we're going to be looking at the ins and outs of how we can use merge to manage data in this session. So hi everyone, I'm Chris Saxon. I'm part of Gerald Wenzel's developer advocate team. It's my job to help you get the best out of Oracle SQL and PL SQL, and hopefully have some fun whilst doing so. So with that in mind, like I say, today we're going to be looking at how you can do, some people call it an UPSERT operation, update if exists, insert if not exists. And we can do that all in one operation with merge statement. So to start off with, we'll just have a quick overview of the anatomy of what merge is. So we're starting off saying that we're merging from a target, from a source to a target table. So the source is the table which supplies the values we are going to load into the target. So we're saying combine those values. And we need to specify the join criteria. So that goes in the on clause. So you can think of this as like an outer join from the source to the target. We want to get all the rows from the source and see if there are matching rows in the target. If there is not a matching row in the target, we need to insert it. And if there is, we need to update it with the values from the source table. How do we do those operations? Well, with the when matched and not matched clauses. So with when not matched, we have insert. And this is like a standard insert, single row insert values clause with an implied into table name. So that's into whatever table we are merging into. So we can have our column list and our values that we're supplying for each of those. So that will add rows to the table. For the rows from the source, which do match one in the target, we want to overwrite the values that we currently have, and we do that with the matched clause. And there we have update. Again, works exactly like, syntactically, it's like a regular update with an implied table name, which is whatever the target is. One thing to note here is the match clause also has an optional delete clause for it as well. So I'm going to talk about a bit more about this delete later on, but an important thing to note here in the moment is the delete only fires on updated rows. So I'll cover that in a bit more detail later on because that subtlety catches a lot of people out when first trying to use this. So we can see we've got our matched when not matched, and with match we can update and optionally delete. Now, another little interesting thing about merge, both of these clauses, when matched and when not matched, are optional. Okay, now you do have to have at least one of them, right? Otherwise you're just essentially doing a join and it's like not doing anything. But you can have an insert only merge, or you can have an update only merge. Now at this point, I will say, I just can't think of a good reason why you would have an insert only merge. Because, if you were just going to load data into a table, you would probably do an insert select, right? Insert select these values. Maybe there is a good reason. If you know of one for an insert only merge, please share. I'd love to hear it. But personally, I can't think of one. An update only merge, you might actually want to do that for performance reasons in some cases. Again, I will discuss that in a bit more detail towards the end of this session, but occasionally an update only merge might be preferable just to do just a normal merge, right? So I see a comment, the doc suggests that update clause should go first. It actually doesn't matter which way around the clauses go. You can flip them, you can do them in either order, and like I say, they're both optional. So you don't have to do them alternatively. And comments, in multi-user environment, even a merge statement might encounter an or1 error if two sentences. Yeah, I mean, it's essentially, you could think of these as like wrapper for insert and update. So if you and I both try and insert the same rows at the same time, one of us will insert and the other one could get the dupe val on index error. Okay, so normal errors that you might get on insert and update also apply. Merge also has a few errors of its own. Again, we'll see one of those a bit later. Okay, so that's the kind of overview of merge. And here, one thing you'll notice is I was talking about loading values from a table. So I've got a source table. But when I started this session, I was talking about receiving data from the client. We got a form which some person's entering details into, and then we want to merge those. We want to do an upsert operation based on those. And we should be sending those in the form of bind variables, right? So they are not a table. So an interesting question here is, well, how do we merge those? We've got our series of binds. How do we use those in merge? And this is kind of a slightly not obvious approach, but there is a nice little trick. You can use dual as the source table and then join the target key columns on whatever your bind variable values are, and then supply the binds in the insert and update clauses as appropriate. So at this point, I'm going to jump to a demo and show you how this actually works, show some examples of this working in practice. So I see there's a whole bunch of comments flying around. I'll just make sure my demo is all set up and ready before we do that. Insert to only add new rows at bulk loading and skip the ones with already existing primary keys at loading fact tables where new install script contains more fact data than the script from the previous version. Yeah, I guess you're using that as an example of an insert only, why you'd want to do an insert only merge. I mean, yes, but I mean, you could do, how is that different or better to an insert selecting the rows that don't exist, I guess is my question. Because I know if you expect there could be duplicates and you want to exclude them, you could do insert select not exists, things that are already in target. You could do that with a merge as well. I'm not aware of any particular benefits of reasons for using merge over insert select, but yeah, maybe I'm missing something. If you've got a concrete example of when one's better than the other, then please share it. All right, see, there's another comment. Maybe the insert merge would be that you don't get an error when trying to insert a row that already exists. But then if you're doing it as a way, so an insert only merge just to ignore the dupe val and index error, I mean, I guess you could do that. That feels pretty shonky to me. There is actually already a hint as well, which you can use to ignore dupe val index errors. I see what you're saying. I'm not convinced that's a great idea though. Okay, because you could also accidentally suppress things. All right, but yeah, I'll take it. There's one way you can do it. All right, so thanks for sharing, folks. So the example. So we've got our, actually it helps if I run my query. I've got my staging table, a bunch of information here, a bit of junk, and here's my actual target table. So let's imagine this is some kind of like data warehousing ETL process, and I've got my dimension table that I'm going to have to load from place some data into a staging table, and I'm going to merge it into my dimension table. So we've got our basic merge here. We're saying we're joining on the customer ID. We can see there you've got our insert with their values, and we're going to set our update as well. So we'll run this. So at this point, this dimension table, or target table, is empty. So all the rows are going to be an insert. And we can see we have merged 100 rows. So we've loaded 100 rows into the table. Just do a quick verification, verify it is doing what I said. Yep, there are 100 rows there. Check that they are the same. Arguably, I should do the reverse of this as well, but hopefully you believe me. They have, in fact, the tables have the same data in them now. So that's with our initial load, we inserted everything. Now, let's rerun the process, but first I'm going to update the names of some of the customers in our source table. So we've got 10 customers with new names. If we rerun our merge, this is going to update all the rows in the target table, even though we've actually only changed 10 of them. So you can see again, we've got 100 rows merged, but really we only actually wanted to do the run the update on things that have actually changed. If they're the same, we're kind of wasting effort there, right? So that's not great. So just kind of again, prove that they have in fact loaded in. But we have updated every single row. They've all got the same update time. So that's wasted a lot of effort. We're updating about 10 times as many rows as we need to. It's not great, right? Be good if we could avoid that and only update the changed rows. So let's just force some more changes in. Let's change the names again. We can, in the update clause, there is an optional where clause. So this filters what we're actually changing. So in this case, we want to say only do the update if the values have actually changed, right? And again, notice this is now a update only merge. I've excluded the inserts just for clarity and simplicity, just to make it a bit easier to see what's going on. So now we can see we've got 10 rows merged. So we've ignored the 90, which have the same value. And just check when they were updated. Yeah, we can see we only updated 10 of them this time. All right, so we saw we can do a conditional update. We can actually do a conditional insert as well. So if I just truncate the table and I'll do an insert only merge this time, just to kind of prove that's really what happens. You can have a where clause for the insert clause as well. So we could have filtering for both the insert and update if we want to, exclude stuff. I mean, the obvious example for the update is ignore stuff that hasn't actually changed. But when it comes to insert, there might be things you want to remove as well. So we can run that and we can see we've got 50 rows merged and we've got 50 rows in that target table now. So we've got insert and update, they're both optional and they both have an optional filtering clause. Now, as I said, here we're using an actual table as the source. But what if you want to use this as the back-end processing for a generic form or a generic UPSERT process? You want to write a procedure, UPSERT customer data, and it receives some values from the client in the form of bind variables or bind values it's sent to you. So we can do that. You see I'm UPSERTing on dual and I'm joining the customer, the primary key in the target, customer ID, to the value that we're using here. And I'll put some names in here. Let's say somebody's, they're born today, so 19th of July. The writing's really tiny. Hopefully you can just about see it on my screen. Customer ID -1. So, new babies are born, first thing they do is ask you what your name. Some people have chosen their names out months in advance. Me and my wife were a bit undecided, shall we say, when our daughters were first born, and didn't know exactly what we were going to choose. So it's actually surprisingly common that babies will be born and they don't have a name initially on birth. So we'll just call it new baby for now, whoever this person is. Yay, new birth. Okay, we've got one row merged in and it's new, so we've inserted it. Again, if we look that person or that row up, we can see we've got our new baby here. So we can use our bind variables. So now we've loaded it. If we run it again, we will do an update. Just to prove this is actually a real live demo, does someone want to give me a name that we're going to supply to our baby, whoever's just been born here, so I can use that as the value here, just prove this is real, right? Well, while someone's giving me a name, see there's another comment. What if someone else runs the exact same commands? Will the data be duplicated after each person commits? I'm not sure. So the thing with merge is it's doing a insert if existing, update if, insert if not exists. I always get this wrong way around. Insert if not exists, update if exists. So the key thing here is if you run it twice, you will still actually get the same output, right? We start with an empty table. First time around, everything's an insert. We load it all in. Second time around, everything's an update. Everything is a change. But because it's all coming from the same source table, the final values in the target table are the same. That's ignoring things like update timestamps and stuff like that for you to find. So in theory, it shouldn't matter, obviously if you're using functions or other things to do this, then they may not exactly be the same, but the values you're taking from the source, if you run it twice, you'll get the same values in the target, okay? So that's one of the nice things about merge. In theory, at least, it doesn't matter if you run it twice, okay? Whereas a lot of other approaches, your own handcrafted upserts might do, or more likely to, at least. Okay, so let's just do that. Someone saying, glad I joined. Using dual is actually a new technique. Oh, good for you to do that. Great to hear. Any way to know how many rows were inserted and how many were updated? Oh, yeah, great question. You're seeing where I'm going with this. So I'm going to cover that in a second, the insert versus update split. What happens if the value compared in the on clause appears multiple times in source? Oh, yeah, I don't know if I'm either you're good at leading on where I'm going or I'm good at predicting what's going on here. Those are both things I'm going to cover in a minute. No one supplied me with a new name. No one was feeling brave. So let's pick it. Let's pick a name. Can I see something? So let's go Ada Lovelace. There we go. So we will put that as the name in. And then we run this again. So now we see we've done the merge. So we've updated this person's name, and we can use this. So like I say, this could be a good generic upsert approach rather than you having to figure out whether to do insert or update. And it works. These could be parameters to a PL SQL function, that kind of thing that we pass in. All right. All right. So any other quick questions or comments before we go on? I will be covering next, I'll actually be coming to the insert update split and the multiple rows. No. Okay. All right. So yeah, if we go to the point there, as we saw when we were executing these merge, we saw how many rows were affected, but all we actually got here was how many rows were merged. We don't know, were they inserted or were they updated, right? And that's SQL % row count telling you how many rows were affected does not give you that split. There isn't an inbuilt equivalent of SQL % row count for merge, which breaks it down into inserts and updates. And this is something which is at least interesting to know, might be useful, and in some cases might actually be necessary to know, what is your breakdown of inserts and updates. So how can we do this? Well, like I said, there is no kind of native out of the box way to do this. So there's some kind of techniques that we can use. The first and probably most obvious technique a lot of people will reach for is triggers, right? So the thing to note here is if you've got any insert or update triggers on the tables in the merge, they will fire as appropriate, right? So any existing triggers you've got on the table for insert or update will fire when that row is inserted or update as part of the merge. There's another interesting thing to be aware of as well. They have different behaviors and different actions. If you run the merge twice, although the results in the table might be the same, the effect of those triggers might not quite be the same. Okay, so there's, again, something to think about there. So we can do this and see if it's inserting or updating and then log it to a table and set a package variable and so on and so forth. So like I say, this is kind of the obvious approach a lot of people will go for, but there are some drawbacks with it. Perhaps the obvious one is triggers have some overhead, right? They're going to slow this process down. How much exactly depends on how you write your triggers and what you're doing in them, but it will actually slow the process down. Next thing to be aware of, and this is probably a more interesting, more subtle problem, and that is to do with something called update restarts. Now, this is something I should probably talk about in another session in its own right. But essentially, if you have two people updating the same rows at the same time, obviously, if I start run an update to update some rows, then you start running it, you will be blocked waiting for me to commit. That's probably not the interesting thing. The interesting thing here is if there are any triggers on that table, they can fire twice for some of the rows, okay? Again, this is something that kind of deserves a bigger discussion in its own right. But the key thing to note here is if we're using this trigger to count how many rows are actually updated in a non-transactional way, for example, incrementing a package variable, we can get wrong results, okay? Important thing to be aware of. So yeah, there's a few drawbacks here, not a great idea. And you know, a lot of people kind of dislike triggers generally because, you know, they hide logic and so on and so forth. So yeah, this is probably best avoided. So what else can we do? Well, another neat little trick you can use is flashback query. So with this versions between syntax, we get all the changes made to the table within that time frame. And by looking up for a particular transaction ID, if you know the transaction ID for your merge, you can see what that operation was. So the versions operation, insert, update, delete. And as long as that, this is the only transaction on that, only operation on that table in that transaction, you can get the split and see what's happened here. So this is pretty neat and pretty cool. Again, however, there are some drawbacks and things, gotchas to be aware of. First up, the information only becomes visible to this versions between query when you commit, right? So if you've got your merge statement and immediately afterwards you run this query, you are not going to see the changes that you have just executed. You have to commit first, which might create some problems for transactional consistency, right? So you have to run the merge, do a commit, and then get this split breakdown, which, yeah, depending on your process and what else is going on, might not be ideal, might cause you other sorts of transactional consistency problems. So that's one thing to watch for. The other thing to bear in mind is, of course, that Flashback uses the undo table space, or undo by default, to reconstruct this history. By default, it's 900 seconds, 15 minutes, and that is, you know, a lower bound guarantee. So if you've got lots of long-running processes, transactions, and you get to the end of it and want to see this merge split, the information might have already been lost. There are ways around this. You can increase your undo retention. You can use Flashback data archive. But point is, out of the box, it's actually quite a narrow window where this information is available. So it's good if you can use this. You can work around these, but may not always be available. Another little trick, the SQL Plan Monitor. So for those of you who don't know, for long-running queries in Oracle database, once they've been going for more than a few seconds, the SQL Plan Monitor kicks in. And what this does is it shows you, or you can see, the execution plan and it updating in real time. So you can see the rows flowing through the execution plan. So this is really, really useful. If you've ever had a SQL statement that runs for an hour, you know, back years and years ago, before this existed, you typically had to wait for the whole thing to finish to actually get the full plan and see what was really going on inside there. With the monitor, you can see pretty much straight away what's going on and get an idea of what you need to change to actually make it faster. Personally, I think this is also actually really interesting and useful for helping you understand how SQL execution processing really works. Okay, so just watching, get a slow running SQL statement and watch the monitor, refresh it regularly, see how rows flow through. I think it's really useful for helping you understand how, you know, execution plans, the different join types work, that kind of thing. The interesting thing here for merge is we've got these lovely cryptically named other stat 1 and 2 value columns. For merge, they actually capture the rows inserted and the rows updated. And this is something I actually only discovered while writing this presentation, because I was looking at some monitors, SQL Plan monitors for my merge, and I noticed it was like, oh, that's interesting. That's there. That's nice. So this is pretty cool. But again, there's no such thing as a free lunch. Why can't we rely on this? Well, this only kicks in for long-running statements, okay? If you've got a merge which runs in 1 or 2 seconds, by default, that is not going to be captured in the plan monitor. To ensure it is, you need to stick the monitor hint in. I mean, it's not too big a deal, but it's something that's easy to overlook. You'd have to retrofit into existing applications, so on and so forth. So just something you could potentially forget about. The other and perhaps more important gotcha is that the SQL monitoring is part of the diagnostics and tuning packs, right? So do make sure you are appropriately licensed to be actually able to use this. So, we see there's various techniques we can use here. There is no one-size-fits-all simple out-of-the-box method which gives you that insert update split. You can create triggers, we can use flashback version query, we can look at the SQL Monitor reports to kind of get that information, but they've all got drawbacks, caveats, which mean they may not work for you in that particular case. So personally, I think the best way, if you need this information, is actually to record it explicitly in the table, right? To have a column or two columns, maybe a column for insert and column for update, where you record what actually happened, right? Maybe you have a run ID or a statement ID to you capture which execution this is of merge and say, did you update this row? Did you insert it? Nice thing about this is that information then persists at least until the rows are next changed, right? So if you need the information after the fact, it's still available, assuming someone hasn't wiped it out and overwritten it, of course, but you can get it after the fact. One potential downside is you do need to query the table again to actually capture this information as things stand at the moment. So there are various techniques you can use here. So you've got to think about, why do you need that insert update split? Which of these best suits your requirements to get that information? So a lot to talk about there on that one. So I hope that helped discuss that. Triggers will serialize the operation though. Will it? I'm not sure what you're referring to when saying triggers will serialize. I mean, unless you're running the merge in parallel, I mean, I'm not sure what you're kind of saying there. I mean, personally, the trigger approach would probably be pretty low on my list of techniques to use here. I think one or more of, let's say, my preferred technique is explicitly record it in the table, but yeah, there's all sorts of gotchas and with triggers. Okay, a couple of other comments. Adding created and last modified works too. Yeah, that's kind of what I'm suggesting here. But I think I'm saying a bit more than that as well. That's a good first pass, but yeah, created, last modified, probably run ID as well, because if you run it twice on different rows, how do you know what to tie it back to? All this information makes me want to not use merge. Why do you not want to use merge because of this? I mean, this is fairly, okay, it's an interesting thing to know, but it's not vital, okay, right? You know, it's, if you could explain why you'd not want to use it based on this, I'd love to know. Okay, another possibility is called a dummy function for one of the branches that increments a global package counter, then subtract the result from SQL sent row counts and the other branch. I mean, yeah, you could do something that gets a bit funky and things like that as well. I mean, when you get package variables, you need to worry about resetting state and things like that as well. So there's, like I say, there's no perfect solution for this as things stand, at least. All right. So we talked quite a bit there, and thanks for the comments, everyone. So we can see there is no easy out-the-box way to get the split. You get how many rows were merged in total, but not the insert update split. If you need that, think carefully about how you're actually going to get it. So another interesting thing that you might run into here, and this is the question someone said, well, what happens if the value in the on clause appears multiple times in the source? You could run this merge and run into this lovely error, unable to get a stable set of rows in the source tables. Interesting. So why does this happen? Why do we get this error? So this happens, as was asked, is you've got many rows in the source which point to one in the target. So in the demo, I was joining on customer ID. Here you can see I've got 3 rows for customer ID in the target. What happens here? So hopefully the first kind of fairly obvious thing is, if we did allow this, it's not clear what the final result would be, right? Because these columns and these rows in the source could all have different values for the names, birth dates, and so on. What's the final result going to be? It's like, we don't know, right? So to avoid that kind of indeterminate behavior, we don't allow it. Oracle database does not allow you to do this. However, what actually happens is when you run the merge, the second time a row is updated, you will get the error. Now, I was being quite careful about what I said there when I was saying the second time a row was updated. It is possible to have this one-to-many relationship, source to target, but if you only actually update the row and the target once, the error is not triggered. There's various circumstances where that might happen and lead to unexpected outcomes. Okay, so the key thing is the error is triggered on the second update of a row. That also has consequences. We're talking about triggers. You know, we could update one row, fire the trigger on that, and we're doing something non-transactional, and then come and update it for the second time and then throw the error. Okay, so we need to think about that. So the key thing is to use merge. Really, there should be, I mean, ideally it would be a one-to-one relationship, source to target, but each row in the source, each row in the target must point to one in the source, right? You cannot have, or you should not have, a many-to-one relationship from the source to the target. If many rows in the source point to one row in the target, you have got potential problems here. And so at this point, some of you might be thinking, well, you know, it's nice of you to say that, Chris, you know, living in your ivory tower, sitting there talking to us about how to build our databases and so on. But, you know, I can't guarantee that. Like, my data model's a mess, right? Maybe you haven't got appropriate primary key constraints on the table, so that there is just junk in that source table. Or, as I said, quite often you might use this as part of like an ETL type process, loading data from another system. And that data from other systems can often be quite messy, and you may not always be able to clean it up before actually doing the merge. For example, that source table or source might actually be an external table pointing to a CSV file. If there's duplicates in that file, what can you do? You can't do anything in SQL. You have to edit the file, and you may not be allowed to, you know, so on and so forth. So, you know, ideally, you would join those source to the target on primary or unique constraints. It's not always practical. So what do you do if you actually have that many-to-one relationship? Well, the thing to remember about SQL is everything is a table. So the source table could in fact be a query, and you can use that query to deduplicate the rows. There are various techniques you can use to do that. Exactly which you use depends on why you've got duplicates and what you want to do about it. Again, I'll show a demo of one way you might want to do this. So we can use that to deduplicate the rows, and use a query here rather than just a table. So we can do that and ignore these extra rows from the source. So we only update each row in the target once. Right, I see there's a whole bunch of other comments or questions. So I'm just going to have a quick look at those. So merge has no returning into clause. Is there a better alternative to use when you need the generated ID other than set count star if count equals 0, insert, else, update? Unfortunately, as things stand, I'm not sure if there is, to be honest. I mean, you can pre-generate, well, can you pre-generate the IDs? Not necessarily. It depends on what you're going to try and do, right? If it's a single row, yeah, you know, you could, I think you'll have to think about what you want to do. Yeah, there is no returning clause for merge as things stand currently. You are kind of a bit stuck with that one, unfortunately, at the moment. If anyone does have better solutions for that, please share or let us know. Right. All right, going back to why you don't like merge, because I feel the rules are totally different from using basic insert and update to remembering all these caveats to think about makes me want to stick with insert update. What rules are different? I mean, the rules aren't actually that different, really. The only difference is you do them both in one statement at the same time. You don't need to think about this. If you don't care about insert update split, don't care. You don't have to care, right? So yeah, I don't think there's any there's extra syntax to know, sure, but I'm not convinced there's extra. While there are a few extra rules, loading duplicate rows in, doing an insert select with duplicate rows is a problem you need to think about when doing insert select anyway. So, I'm not sure these are particularly special rules for merge, for the most part at least. But if you think differently, then please let us know, and we'll see what we can do to discuss. All right, does the error also occur when the first appearance in the source would result in an insert and the second appearance in an update? That's no, because you're processing it twice. If the row appears twice in the source and it's not in the target, then you'll get a dupe val on index error. Okay, so that would be like a regular insert select. So if you've got duplicates in the source and which don't currently exist in the target, they will both form inserts. So one of them will throw an exception. It will get the ORA1 exception in that case. It's only if they both actually do updates. Okay, you won't have a situation where you shouldn't have a situation where one's an insert and one's an update, right? So hopefully that covers that one off. All right. So as we see, we're deduplicating the rows, so we're only updating ones. Now, another thing to note here is we've got rows in the target, 4, 5, and 6, or customer IDs in the target, 4, 5, and 6, which don't exist in the source. Another thing you might want to do is delete those rows. And remember I said that the update has that delete clause for it, right? So some people kind of think, oh, okay, this is pretty neat. Let's just slap that delete in there, and so we can remove those rows. So essentially use this as a way to synchronize the tables so they contain the same information. And unfortunately, first time people do this, they'll run the merge and find it doesn't delete anything. It's like, what? Why doesn't it delete stuff, right? I told you to, right? So the key thing here is, again, as I was saying at the start, the delete only processes rows that were updated, okay? So if we've got rows that are in the target that are not in the source, then the merge won't actually process, it doesn't update them at all, because you can think of a merge as a left outer join from the source to the target, all the rows from the source, and the matching in the target. There's those in the target that are not in the source, we're not going to process them, they're not going to get updated, so they ain't going to get deleted. It's like, so what do we do about this? Well, there's a nice little trick here, the full outer join. Probably one of the few use cases for this, right? I've already said for merge, we need all the rows from the source, even if they're not matching in the target. If we want to do the delete, we need all the rows from the target, even if there's no match in the source. So we need all the rows from both tables with the common ones in common actually joined together. A full outer join. So we can make the source table a full outer join and use that as a way to delete the rows that are missing. Okay, so at this point, I'm going to jump back to a demo and kind of go through those things that I was just discussing. So start off with, I'm going to use these inserted and updated customers as a log so we can get our insert update split. I've got a compound trigger on the table, which is going to build an array for each row, saying whether it was an insert or whether it was an update. And then at the end of the statement, just put them into the log them into the table. So we'll create that. I then got my procedure here, my merge statement. Notice I've stuck the monitor hint in there. So we capture it, because this is going to run way too quick for it to kick in by default. And I'm also going to get the transaction ID so we can see what we've used the flashback query to see what's going on. We'll tie it to the flashback query. I'm going to do an initial merge. I did just truncate the table. Yeah, let me just double check. It's empty to start with. Yeah. So I'm going to do initial merge, which will load everything in. We'll save that. So for this, everything's an insert. I'm then going to make some changes and remove some rows from the target. So we've got 10 updates and 10 inserts, because I'm only going to process the changes here and then run the merge. So this one will insert 100 rows. This will insert 10 and update 10, or at least that's what should happen. Hopefully that's what's going to happen. Fingers crossed my demo still actually works. So let's run that and let's see what it says. Yeah, process completed. And if we look at our log tables, we can see we've got our entries. So we've got our initial insert where we loaded 100 rows. Then we've got our our updates and our inserts. And we've got 10 rows each time. Interesting thing to note here is they're actually triggered at a very slightly different time. Okay, so if you're relying on this time, as I've kind of done here, as a way to join them together to make sure they process part of the same merge, you can't, right? You have to think of a different approach. You probably have to capture like a load ID or a run ID to make sure that these in fact did belong to the same merge statement and not just ones that happen to run very, very close to each other. So we can see that our trigger captured that. So let's look at our flashbacks versions query, and hopefully, oh, I didn't get my transaction IDs. I must have, dang it. Oh well, we'll see what they are. Anyway, so we can see our 100 rows inserted. So that's our transaction. I'll pin this to make sense. So we can see we've got 100 rows inserted. We've got 10 rows deleted. So that's from this delete here. But we haven't got the 10 rows processed insert update from the next merge. Why? Well, remember I said this versions query only shows you committed transactions. We need to commit it first and then rerun this. And now we can see there's our transaction. We can see our insert update split now. So like I say, for transactional consistency, if you want to use this method, you've got to think carefully about how that works. Finally, our SQL Monitor approach, because we had our SQL Monitor, and actually there's a few of them. Oh, see, one's from earlier this morning kicking around when I was checking my demo actually worked. So you can see 100 rows inserted just now, and then we've got merge 10 rows and merge update 10 rows. So actually, I will show you as well. If you've got SQL Monitor in SQL Developer, give it a second. I'll show you the way I discovered this. I discovered this completely by accident while I was just kind of playing around with this. So somewhere in here, we have got, there we go, here's our merge. You can see there's a merge statement that ran. And on the monitor, on this little other thing here, there's a merge insert or update row count. There we go. Merge. So that's how I discovered this. I was just playing around. It's amazing what you discover when you're trying to build a presentation. Anyway, but the key thing here is the monitor doesn't always kick in. It only kicks in for long-running statements. Okay, so we need to make sure we've done that. All right, let's look at duplicates. So let's actually stick a duplicate in there. You can see we've got 2 rows for customer ID 1. I'm going to run this. I'll do an update only merge, and we get the error. It won't allow us to do this. Now, as I said, we actually have a 2-to-1 relationship, but if I only allow the update when the values are different, we'll see it allows us to do this, but we'll flip back and forth. So new name, run it again, we'll get duplicate customer. So we will flip back and forth here between those. Might not be what you want to happen here. So you need to think a bit carefully in these situations. What it would be better to do is have a subquery, use a source as a query like this. So this will deduplicate the rows. And we can see we've got customer ID 1, the duplicate customer appears just once. We've got 100 rows. So that way we can be a bit more sure about what's actually happening. I'll run it once, get 1 row merged. We've got a duplicate, and this should then stop. We're not flip-flopping backwards and forwards anymore, right? Yep, hang on, no, I'm running the wrong thing. That's why 100 rows merged. I thought something wasn't right there. So we've now got duplicate customer, and we'll run it again, and we've still got duplicate customer. So it doesn't matter how many times we run this, we'll always have the same value here. So you do need to think carefully about how this works and what actually happens. All right, let's look at deletion. So let's remove rows from the source. So we've got rows in the target, not in the source. We want to remove them from the target too. I will create a view for my full outer join, just to make my queries a bit easier later. So you can see for the rows we want to remove, I've got this to delete flag. Okay, set that to yes. So now I'm then going to use this view with the full outer join as our merge, and save myself some effort. You know, I think a lot of people when they first try this will do something like this. We say, don't bother updating everything. We only want to remove stuff. So ignore the stuff where to delete is n, and we merged 90 rows. Well, hang on, 90 rows. What about the rows we wanted to delete are still there? We still actually updated everything else. All right, okay. Like I say, this delete only processes rows that were changed by the update. Okay. So this time, if I remove the where clause from the update, and to do that, we merged all 100 rows, and we can see those rows are gone from the target table now. And we look at the SQL monitor, we will see we've got our 10 deleted rows, deleted row count 10. There we go. And if we refresh this, we should see it here as well. Hopefully it should appear. Come on, has it turned up? Yeah, oh, that's the one there, isn't it? There we go, and hopefully this will tell us updated and deleted, yeah, because I didn't do an insert in that one. Okay, any questions or comments on that? Oh, okay, hopefully that's covered the questions or things people wanted to cover. Can we use CS column on delete condition? CS column, what do you mean CS column? Any place where this is documented in the merge documentation, right? If you go to the merge, I mean, what specifically are you wanting to know is documented? That's probably my question, actually. What specifically do you want to know is documented? You know, the documentation on merge covers what I've done there. So the table CS, oh, the source table, you mean, in the delete. So yeah, I mean, this is from the source table, right? Because this to delete column doesn't exist in the target, right? So yes, you can refer to columns from both tables. Okay, if you refer to them in the target, it uses the updated values, the values you get after the updated processed. But yes, you can refer to them. This column is from that CS table, right? Okay. All right. Okay, we're getting, I've got a few minutes left, so there's one final thing I wanted to cover kind of quickly, which is a classic question everyone has when it comes to SQL. It's like, what about performance, right? How does merge stack up? So what I did is I ran some tests comparing this to handcrafted insert and update statements. So for the update, what I did is I used an updatable join view. So I did a join in the update and then updated like this. Okay, so I did updates like this and then did inserts with where not exists. It's like from target, right? So those were my inserts and updates. That's to prevent loading stuff that already is there and ensure we change things. So I actually did 3 tests. I did inserts first and then update, which I called an indate. Sounds a bit weird. An update followed by an insert, which I called an upsert, and then just a merge, which is obviously called merge. And then compared different criteria. I'd looked at what happens if everything is an insert, it's half and half, an equal split, and where everything is an update. First time, and I did this with 100,000 rows coming from the source. Now, average this out various runs, and the first time I ran this test, I ended up with some results like this. Now, I've highlighted a couple of outliers here. The insert update process was notably slower than the other 2 insert everything processes. And the merge process for update was also notably slower than the other processes when everything was updating. And I don't know, I thought about this for a while and I was like, why is this? Why did this happen? What's the problem here? Now, the problem with the insert update, actually, I figured that one out fairly quickly because I was doing an insert that would load 100 rows and then doing an update that would also change all 100 rows because I wasn't doing anything fancy to make sure that values were actually different, right? So essentially we're doing all the work twice. Okay, so that one explained why that process was a little bit slower. But the merge one, it took me a lot longer to figure out. I was like, what's going on there? Why is merge so much slower for update than the indate or the update process? And I thought about it, and then I realized in the merge, I was setting a flag for the update date time to the current timestamp, sys timestamp. But with my update, I wasn't doing that. I was only setting the source. I've got that the wrong way around. I should put target to source. You know, look at slides 10 times and then you do your presentation and find some errors. Anyway, that should be target equals to source, not source equals to target. Anyway, the key point here is I wasn't setting that update flag. And because I'd loaded everything in from the source, there was no actual changes in the values. And Oracle Database optimizes that. If you've got an update which sets all the columns to their current values, it does minimal work. I'm not sure if it quite does no work, but it does very little work compared to if you actually change the values. So basically I've made an error in my test here, and I was like, okay. So why am I telling you this? Well, first up, just point out that, you know, we all make mistakes. This, like I say, this took me a surprisingly long time to figure out. On Friday evening, I was like desperately trying to understand what was going on here. You know, it's easy to get make mistakes doing these things. Perhaps more importantly, it is important to make sure that what you are testing is what you think you're testing is what you are actually testing. It's very easy to write performance tests which show the wrong thing. Okay, you have to verify them pretty closely, particularly when, you know, with queries, you can quite easily check that they return the same results using set difference. When it comes to merge or DML operations, it's a little bit trickier to make sure that things are the same or genuinely the same. Anyway, having sorted all those out so they actually did the same stuff, I ended up with something like this. And we can see actually, no matter what we do, all three of the processes, whether we use update then insert, insert then update, or merge, they all come out, broadly speaking, similar performance. Obvious caveats here is I'm running on Oracle Database 21C. If you're on, I know there are various optimizations or we're continually improving things. If you're on older releases, you may find slightly different results. Again, for your specific situation, your specific behavior, you may end up with different outcomes. There might be nuances of your data that actually matter here. But I think broadly speaking, when it comes to performance, it kind of sort of doesn't really matter too much here, at least in the example when we're loading everything from one table into another. So there was something I want to say in a bit more detail on this though, and that is when it comes to the updates. So I'm just going to reset the tables. So we've got 10,000 rows in the staging table, copy them into the target table, and then I'm going to do some just do some merges, do the various updates only operations on them. So these aren't actually going to change anything. So what I wanted to show you was the plans for these, because one thing we don't necessarily think about is DML, insert, update, delete, do actually have execution plans. So SQL tuning stuff does matter for those. So we can see with our merge, we get a hash join between those two tables, does some work. I've avoided actually changing anything just to make it a bit easier to see what's going on here. So if we do the same with our update join like this, run it, we find that actually we get basically the same plan. It's a hash join between the two tables. If you look at the buffers, how much work we're doing, 136, 136, it's basically the same thing, right? So no wonder these came out with the same performance. Once I finally fixed my test, that was, right? So these are basically doing the same thing. However, it's worth noting you cannot use an update join like this in all scenarios. There are a lot of restrictions on it. In particular, if I start doing anything like sticking analytic functions in here, we cannot do this in all operations. There are some cases where you cannot use this and you have to fall back to like a correlated update. something like this. So you need to check the rows exist. I know I'm changing everything in this case, but I need to do it. This, in a general case, this is what you need to do, and update those. So the thing to note here is we have to access the source table twice, which is always a sign or something to think about in the back of your brain that maybe there is a better, faster way to run this query. If the same table appears twice in a query, and it's not joining on different columns, it's not required by the data model, it's a sign that probably there's a faster, then good chance there's a faster way to run the query. When we get the plan for that, we can see it's actually doing quite a bit more work, and we actually end up full scanning that table twice. Okay, it's not too big a deal on this fairly small table, but scale this up to 10 million, 1 billion, whatever rows, yeah, that might not be too great. So now I was saying you might need or want to do an update only merge for performance reasons. This is that reason, basically. If you have to do a correlated update, merge can often come up with better plans, mostly because then it can avoid accessing the source table twice. All right. Okay, a couple of last things. We're slightly past the hour, so I'll address those, wrap up quickly, and then we can hang around for a few more questions that people want. Can we use table row type in using clause so we don't need to use select row type call from dual? I'm not quite sure what you're referring to when you're saying row type variable and using clause. You can't select. I'm not quite sure what you're referring to there. If you kind of give a more detailed example, we can come back to that a bit later. Not sure if you covered it earlier. One way to improve merge performance is scope down the target table with where predicate. Yeah, only insert current records. Yeah, I say covered. You can have a where clause for both the insert and update clauses there. But yes, good point to recap. Okay, how can source and target records match both on ID equals ID and delete where clauses when one doesn't exist, even with the delete flag? Right. This is due to the full outer join, right? It's because we're getting all the rows from both of the tables. So the source contains the entire data set in that case. If I run this, I'll run that demo again really quickly. So I'll just have to rebuild everything and make sure it's up to the thing. Yeah, that will fly through. There we go. So notice full outer join from between the two tables. Return every single row from the target, every single row from the source, creating that view. And you can see I've got this thing to say, if it's not in the source, set the to delete flag. So these rows here don't actually exist in the source table. All right, they exist in the target table only. But because we've now got this view, our table which includes them, we can join on them. So, if let me just take this out, turn this into a join, you'll notice we get every single row from the table. There we go. We've got all 100 rows. So that's why the full is making that source table into a full outer join that does this. So we got the full matching. Okay. Does that help explain it? If not, if you could articulate in more detail what you're struggling with, and we'll see if we can help you. But like I say, we are slightly past the hour, so I will make some final comments to wrap up. So we say merge. What this allows you to do is do UPSERT, update if exists, insert if not exists logic in one statement. You should use it. I mean, the ideal world actually would be a one-to-one relationship between target, rows and target and source with appropriate primary or unique constraints to enforce that. You could have a one-to-many source to target, but if you have a many-to-one source to target relationship, you're going to have a bad time. Strange things could happen. Things to look for in this. If you want to capture the insert versus update split, we saw there's no simple out-of-box way to do it, but there are various ways you can try depending on what you need to do. You can also optionally delete rows, but only the rows that were updated. So if you want to remove the non-existing rows, you have to make the source table a full outer join. Finally, performance, at least in my tests, on what I did on a 21C cloud database, it actually came out about the same. But it is worth saying that is compared to an update join. If you need to write a correlated update, so a normal update with a set and then a correlated subquery and then exists subquery, merge should almost always be better because you only access that table once. Okay, if you would like to get the scripts for this, then I've loaded them into Live SQL. I've had to edit them slightly just so they actually work in Live SQL and don't fall over in a big heap. But you can get them and download them and try them out yourself. So do take a moment to check them out. They're also on the resources page for this session as well. So there's a link. If you go back to this page, you'll find it and can get those there. One last thing to say, I've got some time off next month, right? So I'm not going to be having holding an office hours in August, and I'm going to be at DOAG and Germany in September. So this is normally scheduled, what is this, the 3rd September, 3rd Tuesday in each month. So it's actually going to be a week earlier than it would normally be in September. So all that's like, I'm going to hopefully enjoy myself. I won't actually be at the beach, but I'll be spending some time with the kids. So I hope you enjoy some time off over the summer as well. I hope to see you back here in September. So that's all that's left to say is really hope you enjoyed this. More importantly, I hope you learned something, and see you next time.